All right, so in our last example, again, you would be given a formula. The formula in this case that they would give you prior to the question, or in the question, would be this. And they would say that P is your atmospheric pressure. In kilopascals, and K is your altitude in kilometers. So, if a cabin pressure in an airplane is less than 70 kilopascals, passengers can suffer from altitude sickness. To the nearest kilometer, at what altitude is the atmospheric pressure 70? So when we get to our formula, what do we know? We know that the pressure is 70. This question is called an exponential decay question as opposed to an exponential growth question because our base is less than 1. So when our base is less than 1, our graph is going to be decreasing instead of increasing. Again, do we know 0.88 from our powers chart? No. This is going to be a calculator question where you're going to put something into y1 and something into y2. This is the formula. So the 101.3 is part of the formula for altitude. It is in the example right beside. So again, they'll tell you a formula. And basically what that formula is saying is that if we put in K as 0, the atmospheric pressure at sea level is 101.3. And then as you go up, it decreases. So we put this into y1, we put this into y2. So 70 into y1, 101.3 times 0.88 to the power of x. And again, thinking about my graph at 70 is a straight line. When x is 0, at sea level, the pressure is 101.3. So as far as setting up my window, I would like to see as my y max, I would like to see that 70. I'd also like to see that 101.3. So I'm going to only go up to 120. My exponential function this time should be decreasing. And if we think about our exponential function and transformations, does it make sense that there's going to be an asymptote at y equals 0? So I'm going to hit graph as a start. There's my 70 line. There's my function decreasing, and according to the window that I already set for my x's from, I think, -10 to 20, it happens to intersect on there already. So when we calculate the intersection, first curve, second curve, and guess, we get 2.9 kilometers. 2.89. So K, does it say to the nearest kilometer? So to the nearest kilometer, at about 3 kilometers, your atmospheric pressure is 70 kilopascals. I'm going to write down your question here, and then I want to talk about this a little bit more.